All right, so let's dive into third question. Which substances are predicted to be water soluble? Very good. Okay, water solubility, the mantra is, let me have a different color. Okay, I'm going to switch to blue again, I think. Okay, when it comes to solubility, if the solubility product, if the charge product, which is charge of the cation times the charge of the anion, just consider the absolute value of that, is greater than or equal to 4, then it's insoluble. Okay, if not, it is soluble. Okay, so we need the charge product to be less than 4 to be soluble. Okay, that's what we're looking for. So let's consider lithium sulfate. Okay, sulfate is -2. It's always -2. How do I know it? That is one of the multi-atomic or polyatomic ions that we need to remember, or that we should have written in our one-page note. Okay, -2. Lithium is always +1 because it's in group 1. So the charge product for this guy is -2. The absolute value is 2. So it should be soluble. Okay, so this is soluble. And aluminum chloride, aluminum is +3. Chlorine is always -1. The charge product is 3. The absolute value of charge product is 3. So that is soluble as well. Lithium chloride, again, it's an easy one. +1, -1, charge product is 1. So we expect it to be soluble. Aluminum sulfate, okay. Aluminum is always +3. And sulfate is always -2. The charge product is -6. The absolute value is 6. Therefore, this is insoluble. Okay, so this is the only insoluble. 1, 2, and 3 are soluble. Therefore, the correct answer is option D. Okay, question 4. Which statement best explains the difference in melting temperatures? Aluminum chloride 192, aluminum sulfate, my goodness, 770 centigrades. Okay, so it should be pretty straightforward. The ionic force, right? So remember, the ionic force is directly proportional to the charge product. We only care about the absolute value of that, and inversely proportional to the distance between the ions squared. Okay, so the charge product, why? So charge product is the primary thing, and then distance between the ions is secondary. Meaning, first we look at the charge product. If it doesn't cut it, then only we look at the distance between the ions. Okay, or mean the size of the ions. All right, so aluminum is +3, and chlorine is -1. The charge product is 3 here. Okay, with aluminum sulfate, aluminum is +3, sulfate is -2. The charge product is 6. So you have a greater charge product in aluminum sulfate. As a result of that, you should expect it to have stronger ionic force. Stronger the ionic force, higher the melting temperature. Okay, aluminum sulfate attractive interactions are stronger due to the size of the anion. No, actually, the size of the anion is larger in sulfate, so therefore it should decrease the ionic strength. So that is not it. Aluminum sulfate attractive interactions are stronger due to charge magnitude. Yep, that looks good. Aluminum sulfate attractive interactions are weaker. No. It says it's weaker in that these are out. So actually, this is between just A and B. So B is the clear winner here. All right, question 5. Cobalt is used in many battery applications. The following solubility data, blah, 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 is shown. Select the PEG diagram consistent with the data to the right. Okay, so cobalt iodide. All right, so you are told that iodide, or IO3, has a -1 charge. Okay, that is going to be important. Okay, so IO3 has a -1 charge. You are told that. Okay, so cobalt, therefore the cobalt must be 2+, because you have 2 of them in this compound over here. Okay, anyway, you got that. And then based on that, the charge product is absolute value of the charge product is plus 2 times minus 1, which is minus 2. The absolute value should be 2. So therefore, we can predict it to be soluble in water. Okay. But that's the prediction, but you are given the data here actually. So we need to go by the data. Whenever the data is given, you're not trying to predict, you need to go with the data. Okay. So that's a different story. All right. Anyway, so apparently, the solubility of ionic, this compound is decreasing when you increase the temperature, right? So because it was 1.02 at 25 and it is 0.7 at 95 degrees Celsius. So it is decreasing. So this is more soluble at lower temperatures, meaning the dissolved state or the mixed state should have a lower potential energy. Okay, so it cannot be this, it cannot be this, it cannot be this. Oh my goodness. Okay, that's it. That's all we had to do there. And that leaves us with this. And also, because we predict it to be soluble, it makes sense that the mixed state has a higher number of configurations. Yeah, usually because usually if they're soluble, they have a higher number of configurations. Anyway, so this is the PEG diagram because the mixed state must have a lower potential energy. How do we know that? Because when you decrease the temperature, solubility increased, meaning the mixed state is favored at low temperatures. Okay, for that to happen, mixed state must have a lower potential energy. Okay, so that's the correct answer there. All right, so that is that. Moving on to the next page, question 6. Aluminum sulfate decomposes to aluminum oxide and sulfur trioxide. What reaction is the correct balance reaction? Oh, okay. We can do it ourselves, or we can just eliminate the wrong answers. So aluminum, we have 2. So if you look at option A, aluminum, we have 2 on the reactant side, 2 on the product side, that is balanced. Sulfur, we have 3 and 3 on the product side as well. So sulfur is balanced as well. And oxygen, we have 12 and we have 12. So that seems really good. Okay, that option A seems to be good. And then this is incorrect because we have 3 sulfur atoms on the reactant side and only 2 on the product side. Therefore, option B is incorrect. I just looked at the sulfur. So if you look at the option C, I have 4 aluminum atoms, okay, on the product side, only 2 on the reactant side. So therefore, this is imbalanced. And then in option D, we have 3 sulfur atoms on the reactant side, only 1 on the product side. And so there are other things wrong as well, but if you find at least one thing not balanced, that is enough to eliminate that option. So therefore, I'm eliminating that without even looking at the other atoms. All right, so for the correct answer is option A. Okay, this guy over here. Question 7, the reaction is endothermic with a charge with a change in potential of plus 268 kilojoules per mole. So the idea is this, okay? So the change in potential energy means when you go from reactants to products, okay? If you have a plus sign, that means it is absorbing energy. If you had a negative sign, that means it is releasing energy, okay? If it is absorbing energy, the products must have a higher potential energy than the reactants. That's the important thing, okay? So for that reason, options C and B are out. And then between A and D, we need to think about the activation energy. So you are given the activation energy, the forward activation energy of the decomposition measured to be a large value. Okay, much larger than the gap between the reactants and the products. Okay, so that is satisfied only in A. Okay, so for an example, so here in option A we have 1544, and then energy gap over here is 268. So that makes sense. Okay. On the other hand, in option D, even though it is an endothermic reaction, okay, the gap between the reactants and the products is too large, right? It is it doesn't seem to be 268. So because if this is 1544, okay, so this has to be at least 1000. The gap between reactants and the products must be at least 1000. I mean, the way it is drawn. So the best answer for this question is option A for that reason, not D. All right, determine the reverse activation energy using the data given. Okay, so now we know that the energy diagram is option A. So the reverse activation energy, if I use a different color, okay, is this guy over here. Okay, so let's say EA reverse. So you see that when you add EA reverse to 268 kilojoules per mole, I'm not going to write the units for the moment because it is not relevant. I mean, it's not going to make a difference now because all of them are kilojoules per mole in our options. This must be 1544 minus 268, right? So it has to be something like 300, 276. Yeah, so it should be a positive value, definitely, not these guys, and then not this one either, because that's the forward activation energy. Therefore, it has to be this one over here, option B. Okay. Question 9, the reaction in question 7. Oh, it's endothermic. Yeah, obviously. Select the statements consistent with this information. The bonds in the reactants are weaker than the products. The bonds. Okay. So it's very. It doesn't involve the data per se. Okay, what matters is whether we understand an endothermic reaction. Okay, so products, reactants. Here's the potential energy, and here's the reaction path. Okay. Anyway, so this shows that reactants have a lower potential energy, meaning you have stronger bonds in the reactants. So statement 1 says the bonds in the reactants are weaker than the products. No, that is incorrect. Okay. The reactants have a lower potential energy, meaning you have stronger attractive interactions or stronger bonds in the reactants compared to products. Statement 2, the products have higher potential energy. Yes. Okay. The reverse activation energy is smaller than the forward activation energy. Yep, that is correct too. 2 and 3, option B. All right. Aluminum sulfate decomposes to aluminum oxide and sulfur trioxide. Select the PEG diagram for the reaction. For the reaction of the decomposition of aluminum sulfate. Oh, okay. Aluminum sulfate. Question 6 and 7. Oh, yeah, it's over here. The chemical reactions are given to you, so you don't have to write it again. Let me erase that. Okay. So, all right, the PEG diagram. So you're breaking bonds overall, right? Because we are going from one compound to 1, 2, 3, 4 compounds. So this needs a net breaking of bonds. If you're breaking bonds, energy must be absorbed. Okay, so that means products have a higher potential energy than the reactants. So products have a higher potential energy than the reactants. And also you see that in the products we have gas. When it comes to number of configurations, gas is called the shots. Okay, the side with more gas molecules, gas particles will have a higher number of configurations. So that again should be products. So products have a higher potential energy and a higher number of configuration. Not this, not this. Yep, higher. This should be option B. Higher potential energy and a higher number of configuration, and not this. So that's our answer. All right, moving on to question 11. Select the limiting reactant in the above reaction. Oh my goodness, there's a lot going on here. The reaction of aluminum oxide with HCl to make aluminum chloride, solid and water vapor. Okay, so we have that. Now the thing is this, our oxygens O2. So we see that this is O2, this is O2 minus, right? Oxide ions. Okay, so that is completely gone now. Meaning we have completely utilized this reactant over here, which is aluminum oxide. Aluminum oxide is completely gone, while we have some leftover or excess HCl, okay, which is our reactant, second reactant. So these are the two reactants. HCl is in excess, therefore that cannot be the limiting reactant. Therefore the limiting reactant must be L2O3. Therefore option C. Okay. And then the products cannot be a reactant, limiting reactant. So anyway, it's a reactant. Okay, write the balanced chemical equation for the given system. Okay. We can write it, or we can just look at what's going on here. So let's do this here. It's easier that way. Now, if you look at options A and B, we have this guy, HCl, on the product side. HCl is a reactant. In the balanced chemical equation, we do not write reactants on the product side or products on the reactant side. Therefore, those two options are incorrect. So we have a 50% chance of getting this right now. Okay. And then between options C and D, let's see. Yeah, let's see whether this is balanced or not. Okay, so L2O3 seems to be fine because two aluminum on both sides. Something happened. Okay, so aluminum is balanced. Oxygen wise, we have we have 3 on the reactant side in option C, but we have 4 on the product side. Therefore, option C is incorrect. So therefore, it must be option D. Let's check that. 3 oxygens on the reactant side and 3 on the product side as well in option D, and 6 hydrogens, 3 times 2, 6 hydrogens on the product side, 6 chlorines and 6 chlorines on the product side as well. So therefore option D is our correct answer. Okay, the PS, okay, that's redundant. PS is photoelectron spectrum. So yeah, photoelectron spectrum for atoms X and Y are given. Select the formula for the ionic compound made when X and Y react. Oh, okay. So X has 1 valence electron. Okay. So the easiest way for the X to become like a noble gas is by removing 1 electron. Therefore, X is going to form +1. And Y has 1, 2, 3, 5 valence electrons. The easiest way for Y to become like a noble gas, meaning have 8 electrons in the valence shell, is by gaining 3 electrons. Therefore, Y would form 3 minus. Okay. Therefore, to neutralize 1 Y ion, you're going to need 3 X plus ions. Therefore, X3Y should be your answer. Option D. Okay. Question 14. Order the predicted melting points of nitrides and oxides. Okay. Now, remember the melting temperature is all about the force, which is directly proportional to the charged product. We only consider the absolute value of that, and inversely proportional to the distance between the ions squared. Okay. That's the first thing I know that should come to your mind when they're asking for the relative melting temperatures. All right. Anyway, so now all of these cations are in the second group, meaning all of them have +2 charge. right? Magnesium, we only have magnesium and calcium. Magnesium and calcium are like directly one about the other, right? So it's magnesium and calcium in group 2, okay? So therefore they're going to form +2, okay? But therefore the anion is changing here. Nitrogen makes 3 minus, while oxygen makes 2 minus. That's the charge. Therefore, the compounds, ionic compounds with the nitride ion or in 3 minus ion must have a greater charge product, therefore should have a higher melting temperature. Okay, so for that reason, I'm going to eliminate, that's all I had to do here, okay? So compounds with the nitride should have the highest one, therefore this is out, because we have magnesium oxide here, and this is out, okay? Because oxide cannot be there, and this is out because I need to see nitrides at the higher end, okay? So therefore the correct answer must be option B. Now we can make sense of this as well. Magnesium nitride, between magnesium nitride and calcium nitride, magnesium is smaller than calcium, because magnesium is 1 row above calcium and it has less shells. Less shells means smaller. Therefore, it's going to have stronger attractive interactions between the ions, because they can get closer to each other. Okay, and or in other words, it's because of the distance between the ions. Okay, and then between calcium oxide and magnesium oxide should have a strong ionic force, hence a higher melting temperature. Why again? Because magnesium is smaller, ions are closer to each other, meaning stronger attractive interactions. Yep, makes sense. All right, moving on to question 15. Okay, select the monomer used to make the polymer polyacrylic acid. Oh, okay. So this is typo. Okay, anyway, it shouldn't be there, but I think they're telling you the answer. Anyway, I'll show you how to do this, because in some exams you will not see these polymer questions. Okay, but in some cases where you're going to see them anyway, because usually this is covered in Unit 3, Module 2, or Exam 3. All right. So here's the polymer. Okay. So to make the monomer, what we do is we write the repeated unit, which is this guy over here. Okay, and instead of drawing these 2 bonds coming out, we're going to have a double bond. Okay, those are the 2 hands. If you can remember the class demonstration, okay, those are 2 hands coming out. Instead of those 2 hands coming out, you're going to, keep the hands together. So that will give us this monomer over here, and that looks like option B. Okay, not A because of this guy over here, and then not definitely C because it's kind of weird. We don't have that here. Okay, that's weird. And then not D because with these 2 are extraneous. All right, question 16. You're given that have been modified. So you modified PA to MPAA to make the polymer more hydrophobic. Okay, because you added hydrophobic or non-polar part than the original polymer. Which statement best describes its behavior? Additional non-polar region causes less interactions with water. That is correct. The loss of hydrogen bonding sites causes less interactions with water. Actually, you do have the same number of hydrogen bonding sites, because you have this hydrogen and nitrogen as hydrogen bonding sites, where in original polymer we had oxygen and hydrogen. So that is not so correct. But those interactions might have been interfered because of this part sticking out, the hydrophobic part or non-polar part sticking out, but that's a different story. The addition of hydrogen bonding sites causes less interactions. No, we didn't add hydrogen bonding sites. We actually added a non-polar region. The removal of non-polar region causes the less interactions. No, we added a non-polar region. Okay, so the correct answer must be option A. Okay. Question 17, which statement is consistent with the expected densities of polymers PAA and MPBA? All right, PAA polymer is more dense due to higher surface area of contact between the chains. Okay, that might be true because of this long non-polar parts sticking out that can act as barriers for molecules to come closer to each other. The umbrellas of my grandmother. MPAA is more dense due to increased dispersion between the chains. More dense due to increased dispersion between the chains. Yeah, dispersion. Increased polarizability is a better term because you have more electrons now. More electrons means more polarizable. But dispersion forces becoming stronger. We'll table that for the moment. We'll come back to AMB. Option C, PAA polymer is more dense due to increased hydrogen bonding between the chains. Increased or more hydrogen bonding sites. Increased hydrogen bonding between the chains. Okay, with the extrinsities of that. MPAA polymer is more dense due to increased hydrogen bonding between the chains. All right, so definitely this is incorrect. Okay, PAA polymer is more dense due to higher surface area of contact. Okay, one can argue this to be correct because, thinking about this part acting as a barrier for the molecules to come closer to each other. And MPAA is more dense due to increased dispersion forces, or maybe they may say dispersion forces between the chains. I kind of do not agree. I don't know. So it's kind of tricky at the moment because if we have this sticking out, that decreases the surface area of contact, that weakens the dispersion forces. So it doesn't have increased dispersion forces, but weaken or decrease dispersion forces. So I'm going to eliminate that. Option C, PAA polymer is more dense due to increased hydrogen bonding between the chains. Yeah. Now, a question like this, okay. If a student can come justify their answer if they selected option A or C, and if they can justify it, I'm okay with that. For an example, one can say that more dense due to increased hydrogen bonding between the chains. Yes. The reason is, with PAA, because you don't have this thing sticking out over here, the molecules can come closer to each other and can have effective interactions, whether it is hydrogen bonding or dispersion or dipole. They must be stronger. So that is not technically incorrect. So this is, I hope that questions like this are ambiguous. So it can be changed so that to get rid of the ambiguity. All right. So I'm going to go with A, okay, because this is the most straightforward one. Question 18. An alternative form of polymer is made by sodium acrylate. Select the statement consistent with the relative strength of sodium and lithium for the polymer. Sodium is stronger attraction with the lowest potential. Oh, yeah. So this is just the attractive interactions between the ions and the anion. Okay. So between sodium and lithium is above sodium, meaning lithium is smaller. If it is smaller, then ions are gonna get closer to each other. It's gonna have strong attractive interactions. So I would say with the low potential energy, strong attraction. This is definitely incorrect. Lithium is strong attraction with higher potential energy. No, that is incorrect as well. Strong attractive interactions means lower potential energy. So between A and D, okay, that's our choice. I'm gonna go with lithium. Strong attraction with lower potential energy, not lowest, lower potential energy, because lithium is smaller and it can come closer to each other, meaning stronger attractive interactions, not A. Okay. Electrical connections are made in polymer using cobalt and molybdenum. Determine the charge of molybdenum in molybdenum carbonate. Okay, this is how we do it. So we know CO3 2 minus, okay, is a multiatomic anion with a charge of -2. It's not going to change. So my anion side has 2 of -2s, okay, 2 -2 charges, meaning anion side has a charge of -4. Therefore, the cation side should have a charge of +4. So because there's only one cation, that must have a charge of, what happened here? Right, it's asking to determine the charge on molybdenum in MoCO3 2. Okay, so I don't see the correct answer here. So CO3 is 2 minus. You have 2 of them, meaning the anion side has a charge of -4 overall. Therefore, the cation side should have a +4 charge. Oh, so okay, so that's an obvious typo. This +2 and this. I think I shouldn't have circled this. Okay, one of them must be +4. So this is that was a typo in this exam. So the +4 is the correct answer. You should make molybdenum 4+ science. All right. So sometimes there could be typos. All right. So question 20: identify what must have been in the box to produce the system or the initial state. All right. So we have. Look, you know what? Let's go with nitrogens first. That's the easiest thing to do because we only have 2 of them. All right. This is a counting game. The numbers should match. We have 1, 2, 3, 4, 5, 6 nitrogen atoms in the final state, meaning in the initial state, we should have had 6 nitrogen atoms as well. Okay, 1, 2, 3, 4, 5, 6. Okay, so let's go to option A. We have 1, 2, 3, 4. Oh, not enough nitrogen, so that is out. Option B, 1, 2, 3. Nope. 3. Option C, we have 1, 2, 3, 4, 5, 6. Okay, looks good. Option D, we have 1, 2, 3, 4, 5. Oh, that's out. 1, 2, 3, 4, 5. We need 6, right? Because we have 1, 2, 3, 4, 5, and 6 nitrogens. Okay, and options A, B, and D don't have them. Therefore, the correct answer is option C. It must be. I mean, if you count the other ones, if you have more time, after finishing all the other questions, go back and check whether we have all the other elements match as well. Okay, because I did not select C because nitrogen matched. I eliminated options A, B, and D because they did not match when it comes to nitrogen. Okay, so they cannot be the answer. So yeah. Anyway. Question 21. Determine the maximum number of molecules of pyrrole that can be made from 50 molecules of acetylene and 75 molecules of ammonia. So this is kind of brutal when it comes to the stoichiometry calculation stuff. So anyway, the idea is you're reacting 50 molecules of acetylene with 75 molecules of ammonia, and they're asking for the number of molecules of pyrrole, which is this guy over here. Okay, you're given the balanced equation, which is great. So now here's what we need to know. Based on the balanced chemical reaction, C2H2 and NH3, to react with 2, we need 1 NH3. Okay, to react with 1, we need 1 over 2. To react with, how many acetylenes do we have now? 50 molecules of acetylene. We have 50 moles of acetylene. We need 1 over 2 multiplied by 50, or just 25. Right? 25 molecules of NH3. Okay, this is what we need. But we have 75 molecules of ammonia. Therefore, ammonia is not limiting the reaction. Therefore, C2H2 must be our limiting reactant. Okay, and once we determine the limiting reactant, okay, to be this guy over here, that calls the shots. And then based on the balanced chemical reaction, okay, over here, with 2 acetylene molecules, we're going to get 1 pyrrole molecule. Okay, so that's C2H2 and pyrrole. Okay, with 2 we're going to get 1. With 1 we are going to get 1 over 2. With with 50, we are going to get 1 over 2 multiplied by 50, which is 25. So 25 must be your answer. So option B. Question 22, select which changes will increase the rate of the reaction. Oh, the same reaction. We're talking about the same reaction here. Add hydrogen, add NH3, and then increase the temperature. Okay, so adding NH3, you are adding reactant molecules, you are increasing the reactant concentration. Therefore, that will definitely increase the rate. Increasing temperature, you are increasing the collision. Particles will start moving faster. They're going to collide more per given time. Therefore, it's going to have a higher rate. And also, you're going to have a higher fraction of particles with an energy greater than the acquisition energy as well. And that's another reason why increasing temperature increases the reaction rate. So options 2 and 3 are definitely correct. Okay. So I'm going to go with option D. That's the best one over here. All right. Yeah, because one can argue about adding hydrogen as well, because that's going to increase the pressure, but that's a different story. Okay, now question 23, pyrrole is immiscible in water at all temperatures. Select the PEG diagram consistent with, oh, that's, okay, so pyrrole must be, when it comes to dissolution or mixing of pyrrole with water, the dissolved state must be in the naughty corner. Okay, the naughty corner is this guy over here, mixed state in the naughty corner. Okay, so that's easy. And use the following energy diagram to select the correct statement regarding the relative speeds of the forward and reverse reactions at a given temperature. The forward reaction is lower than the reverse reaction based on the activation energy, because you have a higher activation energy barrier for the forward, right? Forward reaction. Okay, forward reaction fast. Nope. Because they're talking about activation energy in all cases, right? Reverse reaction is faster due to the lower activation energy. That is correct. Reverse reaction is faster due to the high. No. Forward reaction is faster. No. Due to the activation higher or lower. That's not correct. So correct answer is option B. Question 25. Rank the predicted boiling points of the reactants and products. Reactants and product of, okay, anyway, predicted boiling points. Okay, so now this is the pyrrole molecule. Pyrrole is given here, and that's what they're saying here. Okay, reactants and products, so it's going to end here. Anyway, pyrrole has dispersion, dipole, and hydrogen bonding, because it's a polar molecule with hydrogen covalent bonded to nitrogen. Okay, and when it comes to the boiling point of that should be very high. And in NH3 is the same thing. Okay, you have all three intermolecular forces, therefore should be high. When it comes to hydrogen and C2H2, those are non-polar molecules. Okay, non-polar molecules only have dispersion forces, therefore this should be in the lower end. So this is out. Okay, and then between B, C, and D, let's see. Now this is out as well. If you compare hydrogen and C2H2, both are non-polar, and then only possible intermolecular forces are dispersion forces, but C2H2 has more electrons, meaning more polarizable, with a large surface area. Therefore, it's going to have stronger dispersion forces. Therefore, option A and option D is out as well. Okay, so therefore options A and D are out now. And between B and C, it cannot be B. Okay, because NH3 does not belong here. It should belong, closer to the higher end. Therefore, option B is out, and that leaves me with option C. Okay, and then why would pyrrole have a higher boiling temperature than NH3, even though they both have dispersion, dipole, and hydrogen bonding? Because it has stronger dispersion forces. It has more electrons and greater surface area of contact, because we have trigonal planar carbon atoms over here. Okay, so that's another thing that we can think of. Okay, anyway, so option C should be the correct answer here. Question 26, select the intermolecular forces responsible for the distinguishing the boiling point of NH2 and pyrrole. Yeah, dispersion forces. We just talked about this. Okay, differences in dispersion attractive forces. Yep, that should be it. Not hydrogen bonding, not dipole, same attractive force separated. No, it should be option A. Question 27, cobalt is used in many battery applications. The following solubility data is shown. Select the statement consistent with the data to the right. No, I thought we did. Oh no, yeah, this is the same thing, but we did the peg diagram of this before, I think, somewhere over here. Yeah, so we decided the peg diagram to be this. Okay, so therefore the mixed state has a lower potential energy, meaning mixed state has stronger attractive interactions. I think that's what's important here. Okay, so it's an ionic compound. In ionic compound, what we have is the dissolved state and the undissolved state, or the mixed. This is also known as mixed and unmixed. Okay, same thing, same idea here. In ionic compound, in the dissolved state, we have ion dipole interactions, so ion water interactions. No, it's called ion dipole. That's the term they are using here. Ion dipole. And then in the undissolved state, the strongest interactions are ion-ion. I'm only considering the strongest interactions in the two states, because there are other interactions like intermolecular forces and stuff like that, but they are relatively weak compared to ion dipole and ion-ion interactions. Okay, so because we have the mixed state at a lower potential energy, because this is the peg diagram. Okay, the mixed state should have stronger attractive interactions, meaning ion dipole interactions must be stronger. Ion dipole interactions are stronger than dipole and yeah, so I don't know why we pick ion-ion interactions. Okay, so this is correct. Ion dipole interactions are weak. Nope. Ion dipole interactions are equal. Nope. And then a peg diagram is necessary. I mean, you can use a peg diagram. You don't need a peg diagram. Okay, you know that you have a higher solubility at lower temperature, meaning the mixed state or the dissolved state should have a lower potential energy, meaning in the ion dipole interactions, which are the interactions in the mixed state, should be stronger than the interactions in the unmixed state. That's it. So the correct answer is option A. All right, I think that's it. We went over 27 questions. I hope this helps. I'll see you guys in class. Bye, everybody.